is from equity valuation. All right. It's going to deal with the common stock DDM stuff. And it's going to be a two-part question. Okay, it's a two-part question. And I really feel like equity valuation questions are honestly, once again, like chapter 5. And that's why it's that much more crucial to use a timeline to your advantage. And once again, for equity valuation questions, especially those dealing with DDM, there's not like 1,000 formulas that you need to use. Okay, there's one classic formula that you need to use. All right, it's only this one. Don't get it twisted. It's as easy as that. So when you see this, you know that you're only looking for 1, 2, 3 variables. Okay, so when we are dealing with common stock DDM questions, you're only looking for 3 variables. That's your only goal. Okay, remember that. You're only looking for 3 things, and then we just need to place them onto our timeline. Okay, that's it. We just need to place them onto our timeline, and I'll draw another one just for fun, just so it's really clear. There you go. So they're all the same formulas, just written in different ways. So Onitsuka Tiger is an amazing company based off Japan, really solid, and they're expecting a period of intense growth. Okay, so they decided to retain more of their earnings to help finance that growth. As a result, it's going to reduce its annual dividend, okay, by 10% a year for the next 3 years. Okay, so this is very important. We know that its annual dividend, its growth technically, will be essentially 0.90, right? Because it's going to lose 10% every single year. All right, it's going to be 90% of what it's supposed to be. All right, that's one way to look at it. Essentially, G is going to be decreasing every single year. If you want to like have like a type of vibe, it's going to decrease for 3 years. So we could even change this if we want to. Even change this into its own color because we want to put it in its own category. So this is part 1. Okay. After that, it will maintain a constant dividend of $0.75 a share. Okay, and you want to assume that that's going to happen forever. Okay, the company just paid a dividend of 1.80 per year. Okay, $1.80 per year. So they just paid a dividend of 1.80 per year. Right, just paid a dividend of 1.80 per year per share. Now we're asking you, what is the market value of the stock? In other words, what's the present value of the stock if the required rate of return is 13%? Okay, if your K is 13%. Now, before we go, I would like to just ask you a simple question. When we say just paid a dividend of 1.80, obviously I know beforehand, but the simple way will lead to be able to understand whether a question has different parts is by simply like kind of either doing a timeline as you read the question or really rereading the question afterwards. So we know that the dividend is going to decrease for 3 years. Okay, right? The dividend that we just paid is going to decrease for 3 years, and then it's going to become another dividend. So obviously the growth or the loss of 10% per year is not sticking for more than 3 years. After that, we're dealing with a different type of dividend, a constant one. So having that in mind is important. Okay, let me give you an example, and we're going to actually use our timeline to do so. But before we do so, we'll need to really like answer the question. I would like to ask y'all, when we say the company just paid a dividend, what does that mean? Is that D0, D1, D2? What are we at? We're at D0, exactly. So this is D0. It's very important to understand. All right, so let's draw up our timeline real quick. We know this is T. We're just going to go like this. Okay. Honestly, we don't need to do all of them, but at this point, I might as well. So we know that a dividend of $1.80, so D0, was paid here. That we know for sure. That's a fact. Okay. So I don't know why I said that like that, but so what we know in this question is that the annual dividend is going to decrease by 10% a year for the next 3 years. So we know that our 1.80 is going to decrease here, and it's going to decrease again, and it's going to decrease again by 10%. So we're losing 10% every single year. Okay? So D1, D2, and D3, that's one section of the problem, essentially is a dividend, all right, that's decreasing by 10% every single year. And because we know it's only going to happen for that period of time, we could put that as it being its own part, okay? So we could call this part 1, right? It's easy as that. But then in the question, they're telling you that they're going to pay a constant dividend, essentially forever, all right? If they don't say anything else about something happening afterwards, you want to assume that that dividend is going to occur forever, okay? So in this case, we know that starting D4, we have a dividend of 0.75, right? And that 0.75 is going to happen forever, all right? I'm obviously not going to write every single one of them. That would be wasting your precious time. But it's important to know that this is going to occur forever. Okay. Part 2, constant. Okay, so this is really, really, really important to do when you're dealing with these types of questions on an exam, if you have the time, and especially when you're practicing, such that you're able to get the big picture of what's going on, okay? So far, does everybody understand what we wrote on our timeline? Do you guys see it? Does that make sense? Everybody, like, or does anybody have any questions? Just to make sure, because I understand that, it's maybe a little bit of a lot of stuff, okay? All right, so this is awesome stuff. Now I'm gonna ask you guys a funny question, okay? Actually, I'm gonna start by giving you guys a statement, and then I will give y'all a question. The first thing is the statement, all right? The present value of a stock, the price of a stock, in theory, should be equal to the sum of all of its future discounted payments. In other words, the price of a stock, or the market value of a stock, should be equal to the present value of all of its future discounted dividends, okay? Essentially, you just want to discount all the future cash flows to find the value today, which is exactly what we're doing with like our perpetuity formula, right? Like right here. We're looking for a P0, so we're discounting our cash flows. Now, I have a 2-hour clip where I talk about this. I just want to say that one more time, okay? And now my question, which is funny. Is a perpetuity something that's lasting forever, or is it something that lasts only a specific amount of time? Can somebody tell me in the chat? Is a perpetuity something that lasts forever, or just a specific amount of time? I need everybody to give me an answer. Is it something that lasts forever, or only a specific amount of time? Diane says forever. Come on, everybody else. What is a perpetuity? It's an infinite series of payments. It's a cash flow. It's a set of monies that you're receiving forever. I hope that we're all okay with this. Okay? Now let me ask y'all a different question. Part 1, all right? What we have right here. Is it lasting forever, or is it only lasting a specific amount of time? Part 1. How long is part 1 actually lasting? Only for a certain amount of time. Part 1 literally lasts only 3 years. This is a specific amount of time, okay? 3 years. I'll put it in its correct color. But yeah, 3 years. So it's a specific, and it's for 3 years. So let me ask you all this. Would it make sense to use a formula like these ones? Would it make sense to use these? If these are perpetuity formulas, would it make sense to use it on part 1? Somebody tell me in the chat. If these are all perpetuity formulas, would it make sense to use it on part 1 if part 1 only lasts 3 years? Would it make sense? Why would you use a perpetuity formula on something that only lasts 3 years? Okay, that's super, super, super duper important. Exactly. All right. So that's crucial. It's very important to see that and to understand that. Okay. So and let's use our flowchart again. Okay, this is getting really funny. If this is a specific amount of time and these payments are happening at the end of the year and they're growing or decreasing by a specific amount every year, what formula are we going to use? I think we just looked at it too. If we look at our flowchart, it's a defined payment because it's only lasting 3 years. These payments are occurring at the end of the year, and these payments are growing by minus 10% every year. What formula are we going to use? I'll draw the flowchart. We go like this, like this, like this, and like this. We have a growing annuity. Exactly, a growing normal annuity. Amazing. Okay. So key takeaway here. On exam questions, it's very common for them to do this. Okay. Where the first part, sure, they're dividends, but they're not occurring in perpetuity, the first part. So you cannot use a perpetuity formula. And countless students make that error. And they're funny people on the exam, right? So they'll put the answer with the error out there because they know people are going to make that mistake and they're going to, plug that in and select that multiple choice. So that's why it's important for you to use a timeline and to be sharp and to understand that this only lasts 3 years. Therefore, we must use our growing annuity formula. Okay. So for part 1, we're going to have PV0 equal to payment 1 over K minus G, like this. 1 minus 1 plus G, 1 plus K, power of N, like this. All right. That's going to be our formula for the first part. And obviously, we have all of these variables. We need, can somebody tell me what's payment 1? Just for fun. What's payment 1? Thank you so much, Shane. Yes, that's payment 1. Payment 1 is at D1, not at D0, Waleed, right? D0 is here. We need payment 1. Yeah, it's okay. On the exam, that's why it's important to write it down one by one. Our K is going to be essentially 0.13. Can somebody tell me what's our K really quick? What's our K? I mean, what's our G? Sorry, what's our G? What's our G? What are we going to plug in here? Is it 0.1? If we are reducing, if we're reducing by essentially 10% every year, what is our G? Can somebody tell me? We're reducing. Oh yeah, my bad, everybody. I don't know why I'm like I was on some sort of black magic, but yeah, exactly. So it's essentially minus 0.1. Okay, minus 0.1. I saw some of the answers in the chat. My brain was fried a little bit for 2 seconds, but it's important to understand that our G is minus 0.1. Okay, minus 10%. All right, so it's not 90% or anything of the sort. It's minus 10%. Okay, so very important, and I guess I'll highlight them right here. So payment 1 is going to be 1.8 times 0.9. Your K is going to be 13%, and your G is going to be minus 0.1. In other words, minus 10%. And our n, can somebody tell me what is our n? 3. Solid. Now, really quickly, what are we going to put here? What are we going to put right here at our numerator? What are we going to put here? 1 plus g. What is 1 plus g? 1 plus minus 0.1. What does that give you? Yusra says 0.9. I need maybe one more person to write it in the chat, just to make sure that we're all on the same page. That is 0.9. Yes, exactly. So on that note, could somebody tell me what's the present value of part 1? What is the present value of part 1? Somebody write it in the chat, please. Solid. Amazing stuff. Okay. So once again, key takeaway, because D1 to D3 is not lasting forever, obviously, we need to use our normal growing annuity formula. However, part 2 onwards is literally a constant dividend forever. Okay? So if it's a constant dividend forever, now we could use our constant DDM formula. Okay? What we could do here, okay, we could simply do P over, well, because it's not growing, literally P over K, to be honest with you. We could do P over K. That's going to be equal to Pn. Or if you want, you could just remember our formula. Over K. Or even this formula if you want. What I'm trying to say is that these are all the same thing, right? We have this constant payment that's not changing forever, and we have our K. So in order for us to find the present value of this, you simply have to take that constant payment and divide it over K. So in this case, our Pn will be equal to, once again, payment n plus 1 over K. Therefore, we know that P3 will be equal to payment 4 over K, such that we know that P3 will be equal to 0.75 over 0.13. Can somebody tell me what P3 is equal to? Walid says 5.76. That can be fair. 0.75 divided by 0.13. Okay, cool. Thank you. So we know that P3 is equal to 5.77. All right. Now, can somebody tell me, is this here, or is this here? Where is this on our timeline? Where is this on our timeline? I need a few people to write it in the chat. There you go. It's at P3. The reason why it's at P3, a few things. The first one is to understand that the formula literally says n plus 1. So in this case, if payment's at 4, then it must be at 3. Another way to look at it is that for a perpetuity, no matter what, the payment, okay, the first payment that we're putting into our formula will always give us the present value of period before, such that our present value is at t equals 3, okay? It's at PV3. Now, obviously, PV3 is not PV0. So we need to discount P3 for 3 years to P0. That's going to give us a present value of part 2. So what we're going to do is we're going to do P3 power of 3. So P0 will be equal to this. So could somebody tell me what 5.77 over 1 plus k to the power of 3 gives us? No way it gives us $4 on the dot. That's crazy. No way. Yo, math's wild and right now. That's facts. Okay. Yeah, it gives us $4. You're right. 3.99. Oh, we'll go with 4. All right, I like 4. 4 is nice. Obviously, on an exam, you want to round it up, but you don't want to round it up, but still, I just find that so funny. Cool. All right. So now, once again, what did I say at the very beginning of our session is that the present value or this price of a stock is equal to the present value of all of its, cash flows into the future. So in this case, if you want to find the price, the market value, I guess we could write it in blue. The price would be equal to P1 plus P2. Somebody tell me what the price today is then? Part 1 plus part 2, it's simple math at this point, 4 plus something. What is the price today of this stock? There you go. Honestly, when you break it into its parts, so this question is really easy, right? It's literally a flowchart type of question, but it's camouflaged in dividends, in equity valuation, under the constant growth DDM section. But with these questions and like people who are in finance in the course right now, by the way, in FINA 385, in FINA 395, or whatever course you're going to take afterwards, they're going to send you questions like these at the beginning of the semester. And you'd be surprised how many people still get it wrong. It's really important to use a timeline. Visualize what's going on. It makes no sense. Remember this, please write it on your cheat sheet. It makes no sense to use a perpetuity formula when you're actually dealing with an annuity, okay? It doesn't make sense. So for that reason, we had to make some adjustments in that question. Before we move on to the next one, are we okay? Are we good? You see this on an exam. Do you know what to do? Yes or no? Any questions whatsoever? How are we feeling? I know we're going through a lot of stuff. Like we're going through high level stuff, but are we okay? Quick yes or no? Yeah, we're good? Feeling good? Amazing. Good stuff. Okay, let's keep on going.